Yes, guys, I'm today really very much happy with this content today. DevOps day-to-day activities, Kubernetes issues solved, debugging common pod issues in AWS EKS. And these common pod issues here, I have listed here five. These five pod issues coming too much in the real time. And honestly, if you can solve these five kinds of problems in the real time, you will be just pro in the Kubernetes. And in the interview, if you can explain these five kinds of issues, I believe you will be hired. 99% I'm sure you will be hired. So let's see the overview first here. CrashLoopBackOff. When coming the CrashLoopBackOff, just think that config problem, config, configuration, just simple thing. And learn one time, use lifetime. I say this one always. After today, don't no need to think about Kubernetes problems, issues if you watch the whole video. And of course you have to do hands-on. And here this is ImagePullBackOff. It has the name is saying that the problem is image. That means Docker Hub or Elastic Registry. Where is your image? Docker build, then Docker push, right? Image is pushed there. There is the image name. So image name problem, actually this is the image name problem, is the ImagePullBackOff. Very simple. So please keep in mind that ImagePullBackOff, the problem with name, that is finished. Then insufficient resources, showing also pending. So insufficient resource when coming, then just please keep in mind that you have to add the resource, memory and CPU. So solution is memory plus CPU. These two things you have to upgrade, you have to add some resources there. And readiness probe failure, and the name is saying the readiness, that means readiness time. This is the time thing, problem with time. So if there is a seconds, best practice make it hour, 1 hour, like that. Too much, make it 10 minutes. Okay, so unlimited time, give the readiness, then it will be easy. It will be just rounding, then it will be ready if everything okay. The liveliness probe, this is some tricky. So when I was new, the liveliness, I thought that is the time. No, liveliness problem with health check. Health check, you know the EC2, when you opening the EC2, there is a health 2 by 2, right? So same way in the pod level has the health check. If health check is okay, then this is live. Oh, I'm wake up, I'm so boostful. This is the for pod. If pod is not healthy, then just problem. Please try hands-on. After watching this video, please try hands-on. And I am adding this one in my here GitHub DevOps 0 to hero. I'm adding one more file here, just creating and paste is here, so you can get everything here. Yes, so debugging Kubernetes pod issues, I'm just creating this one. It's here, debugging Kubernetes pod issues 0 to hero. You have to come here, and this is my YouTube channel. It will be added here, and there is a lots of playlist. You can go there, especially the AWS DevOps series, very much helpful. Also interview crackers, also troubleshooting, you can go there. And CI/CD pipelines, Python, everything is very much helpful for you guys. Job ready project, you can go there. Okay, so let's go to the real project. First of all, I'm creating a Bastion server. So always starting with the Bastion server. That means one extra EC2 instance. This is also interview question. What is the Bastion server? I'm giving the name like Bastion server using Ubuntu. T2 micro is okay. Keep here I have. If you don't have, just create from here. I'm using my default network and security group. I'm using the default one. It has all traffic, 8 GB byte, GP3, everything is good. Yeah, launch traffic. Yeah, it's running, but initializing is still. Let's take the public IP here. Then I have to go to mobile extreme. Session, remote server or host, specify username Ubuntu or Ubuntu, private key, this is for the default key. Yeah, it's done. Control L, making some bigger. Okay, now I'm taking from my paste repo in the GitHub, AWS CLI kubectl EKS ctl. So everything from here I'm taking, copy, then just paste. So here is first of all CLI installation, then kubectl. Actually, first of all it should be upgrade, then fully update and upgrade, then CLI, kubectl, EKSctl. These three things going to be installed after update. It will take a bit time. So 70%, 80%. It's going some time. So this is called the environment installation or environment implementation. For EKSctl I'm making this one. Inflating. Yeah, it looks good. So at last this one should be had. Control L. So ls, showing nothing here. So first of all see AWS version, CLI version 2.24, then see, let's see kubectl, then let's see EKSctl. So all are version available, that means everything looks good. Now yes, I have to do AWS configure. So access key ID and secret access key ID is needed. I have to take it from identity access management. It's here. That means I have to make one more user. User has API call. So user is needed here. So I'm giving the name like EKS user. Attach policy or permission, administrator access, next, create user. So this one is today. Okay, let's go inside. I need the security credentials. So this is for access key, CLI access. I confirm, create. So in the real project you have to download this one, but after this demo I'll just delete. So this is the access key, this is the secret key, default region US East 1, output is JSON, looks good. Always recheck with AWS S3 LS. Yes, it's connected. These guys are with me in the S3 bucket. Okay, so now I have to do EKS CTL. I have to use for node. I have to create. I'm using bash command. So EKS CTL create cluster, then name my EKS cluster, region US East 1. You can change your name from here. You can change your region also. Node group name, my nodes. You can change also this one. Node type T3 medium, and desired is 2 nodes. Okay. So let's try. It will take 15 minutes minimum. It will create first VPC, then it will go with add-ons, everything. And this is using CloudFormation to create. So let's see the CloudFormation. We can see there CloudFormation. Open. Yes, so my EKS cluster, the cluster name in progress. We can see also VPC. VPC is creating first. Right click, new tab. Yes, it's coming. Yes, my EKS cluster, this VPC is being creating. Always see the roadmap. So I'm watching the roadmap here. Yes, so private is connected. That means NAT gateway is created. So yes, it looks done here. At least I have to see here first. kubectl get node or nodes, same thing. Here is 2 nodes already here. Let's recheck our stack. This is done, and let's recheck the node. That means EC2 instances. It's coming. Yes, this one and this one, these 2 nodes are created. And also let's recheck the EKS Kubernetes service. Yes, this one is created, and compute has the node group. My nodes desired is 2. So if you need to add the node, just go add node group. You can add from here also. And add on kubeproxy, core DNS, metric server, VPC CNI. These add-ons are added here. Okay. Now let's make the alias. I like alias. Alias k equal kubectl Okay, then alias kgp kubectl get port or port, same thing. So then kgs kubectl get service sbc service. Okay, so now let's check here. We don't have the port right now, we have the by default kgp. So namespace is kube system by default. So by default always coming this one 1 2 3 4 5 6 7 8. So this nodes by default. So core DNS very much important for networking, proxy, kube proxy also for networking. Then here is the metric server. All are good now. Now we have to add some YAML files. So first of all, I'm doing CrashLoopBackOff. This scenario I have to do. So vim CrashLoopBackOff, this YAML file. So I'm just copying from my notepad. I have added this one in the GitHub. So here is the API version, then kind is pod, metadata, name, CrashLoop pod, spec container, name busybox, image busybox, arg sleep. This is container exits after 10 seconds. Okay, ask wq. So after anything changes, let's see first. CrashLoop pod.yaml is here. So kubectl apply. That means k apply -f, then CrashLoop, just C, then tab CrashLoop. Okay, so this is now created. This guy is finished. Next, ImagePullBackOff. I'm just taking from my notepad. Vim ImagePullBackOff. So inside I'm giving the pod. I'm taking from my notepad. So this is the kind of support, but name is ImagePullBackOff here, and spec containers, name invalid image, name invalid image. So I'm making something scenario for you guys, why the pullbackoff, why this is like this happened. So this is now image pullbackoff. Okay, so k apply pod is created. Now I'm doing insufficient resources. Why happened this one? So vim insufficient resources pod. So here also I'm adding the insert, then pod metadata name insufficient resource pod, spec containers name stress, image busybox, then resources request memory 10 gi cpu 4. So insufficient resource I'll show you from here. So k apply, then -f insufficient resource, right? Yeah, it's created. Then I have to create readiness failure pod. Okay, vim readiness failure pod. Then inside I'm giving the information. So name readiness failure pod, then inside contain spec container name, Under the container name, the readiness probe. So here is the readiness probe, has HTTP GET path. This is port here. Initial delay second is 5, period second is 10. Ask WQ. So then after any changes, I have to do k apply kubectl apply -f, that means file readiness failure pod. This is created also. Now I have to add liveliness failure pod. Readiness, liveliness, two things very important in the interview. I hope today's demo, it will make very much clear for you guys. Liveliness failure pod, spec container name, image, args, arguments. This is the argument. Liveliness probe, ask command is coming, this one. Initial delay second 5, periods seconds 5, ask colon. Yes, so after this I have to do k apply -a file l, then tab. Yeah, pod is created. Then yes, Control L, let's see how many. See here, crash loop pod. This is CrashLoopBackOff. It's not ready or running. Then ImagePullBack pod is showing us ImagePullBackOff. Then insufficient resource pod, this is pending. So when the resource is insufficient, on that time this is problem, is showing that pending. Liveliness failure pod, this guy is luckily running okay, because liveliness means actually your pod should be ready. So my internet is good now today, and it was the time, how many times liveliness, 29 seconds, that means more than the 5 seconds is running. But readiness failure pod, this is showing running but 0/1, that means not ready. This side is for running is good, and this side is for ready. So ready, not good. So the slash always making the separation. First side is for ready, second side is for status. Okay, so I have to do now debugging CrashLoopBackOff first. So I have to go inside. I have to describe first CrashLoopBackOff 1. kubectl describe pod. Which one I have to describe? Pod. Which one? CrashLoop pod. The name. Pod name should be here. Okay. So see here. Always see the red one. Failed. So configuration is failed. Restarted, then also failed. That means configuration issues. So vim CrashLoop pod insert. So here the argument section, I am just making the sleep not 10 seconds, it should be 3600, 3600. That means 60 minutes, 1 hour I am giving here. So ask colon WQ. So after changing anything, I have to do k apply -f, then CrashLoop pod. Why this has happened? Because my pod is running. Okay, that one should be deleted. So Control L, So KGP. So first this pod should be deleted. Delete pod, then crash loop pod is deleted now. After deletion, now I can do apply. Yes. So this is also troubleshooting I have showed. So without deleting the existing one, you cannot do. So KGP, let's see here now. See now crash loop pod is running. So one by one, always make sure this is ready and status is running. So you have to change the configuration. When crash loop pod is coming, crash loop back off, this question is coming, always say that the configuration, especially the arguments, normally the sleep time, if we make it more, then it's working good. Okay guys, so now I have to say that describe this one, ImagePullBackOff, this one, what's happened inside. Describe pod, which one, image pull back pod, this is. So see always the failed to pull image, invalid image name. So my image name is invalid. Okay, I made this is to make the demo, So Vim image pull back off, I have to edit this one. So this name should be busybox, the image name. I have given the invalid image, right? So this one should be busybox, or your image name, anything else, busybox. Okay, then colon WQ. So now also I have to see KGP because I have to delete this one, ImagePullBackOff pod, right? Okay, delete pod, ImagePullBack pod is deleted. Now kubectl apply -f file ImagePullBackOff. Now this is created. So our CPU memory GB byte to maybe byte MI, I'm taking this one, and this is CPU I'm making 500 M. So it should be now working. Let's see. This combination is good. So KGP, delete pod, the pod, which one is problem? This one, right? It's deleted. Apply -f insufficient resource. Okay, KGP, yeah, insufficient resource pod is running. Yes, and liveness probe, actually this is automatically done. There is no problem is there, but readiness failure, running means not ready. Let's see the readiness failure pod. What's the problem? Describe readiness, this is the pod, readiness failure pod. See the last line always. Probe, readiness probe failed. HTTP probe failed with status 404. That means not found. Okay. So when the readiness problem is coming, Then we have to do our HTTP problem is here. So beam readiness failure. So here HTTP GET path is actually non-existent path. See here, I have given intentionally. So this path should be erased. It should be only this one. Then port is good, everything is good. So path was problem, yeah. Describe, see here, HTTP probe failure with status. So that means the path problem. KGP, I have to delete, delete port, this one, readiness failure port, deleted. Okay, apply -f, then readiness failure port is applied. KGP is taking a bit time. See here, running. First it was not ready, now this is ready. So readiness take the time, 12 seconds it was, right? It takes a bit time. Let's see the readiness again. The initial delay second is 5 and period second is 10. Let's play with this one. Beam readiness probe inside, initial delay second making like 15 seconds, 15. Okay, WQ. Now again delete first this part, then apply KGP. See here, it's not done, 5 seconds. Doing KGP again, 11 seconds, not done. Readiness failure. And now we hope it should be done. Yeah, 22 seconds. This is now ready. So guys, this is the thing, KGP. Let's see first. Oh my bad, Control L, KGP. So always see one by one, ready and status one, status ready, okay, status okay, then one by one. And this 1 2 3 4 5, these 5 kinds problems coming too much in the real time, and also in the interview will ask for this one. Okay, so guys, please do practice more and more for this one, and don't forget to delete your cluster. Okay, this one I have to delete EKS, my EKS cluster, because cleanliness is very much important. It taking times also. You cannot delete from here. Say stack. This is stack, right? And very much important. If you delete the stack, cloud formation is stack, delete in progress. So after deleting this one, actually you have to delete this one first, then it will be deleted. And also make sure your EC2 has auto scaling group here, because auto scaling is this is the desired one. So you have to delete this one, auto scaling, otherwise money is coming too much. Also go to BPC. BPC here is the NAT gateway. So NAT gateway, just do delete, because NAT is taking too much money. deleting. Yes, it's deleting. So your which one is taking the money, those guys are deleting now. Also, so guys, this is the high level everything. After deleting, it will no more here. And yes, I'm coming with something important next one also. See you then. Take care. Bye.